Okay, here we are back again for the VCAA 2021 physics exam, section A, and so we're up to question 11. And so we've got some information here to answer questions 11 and 12. Okay, so force versus compression graph for suspension of spring is shown below. All right, here we go. So first thing before we even get to the question, take note of the units here. It's in kilonewton. Oops, what am I doing? Not kilonewton, kilonewton. Okay, so kilonewton. So when we do any calculations, we've got to take that into account. All right, first question says, which of the following is closest to the spring constant? Okay, so the spring constant for a force compression graph or a force extension graph, the spring constant is our gradient. All right, so rise over run if you like. So all we need to do then is that K would be 4. Now remember that's 4 kilonewton, so that's 4,000 newton. And for 4,000 newton, it's 0.04, and it is already meters, so I don't need to do anything with that. And when you get your calculator, you find that that comes out to 100,000. And so the question is, which one of these is 100,000? Well, if you have a look, 1, 2, 3, 4, 5 zeros. D. All right, question 12 relates to that. The spring is compressed to 0.2 meters. Okay, so or 0.02, I should say. So we've compressed the spring to here. Which one of the following is closest to potential energy stored in the spring? So there's a couple of different ways that you can do this. You can work out this little area down here, and that would give you the answer. Alternatively, you can use the formula for the potential energy of the spring, US, which is a half kx squared, and so that's a half times 100,000 and 0.02 squared. And when you figure that out on your calculator, you get 20 joule. And if you did half base times height here, you would get the same. But again, just point out that that height is not 2, but 2,000. All right, as to which one to use doesn't matter. All right, then question 13, a lucky question. And we'll get to it. Here it is. A diagram below shows part of a travelling wave. The wave propagates with a speed of 18. Which of the following is closest to the amplitude and frequency? Okay, so our amplitude is from our midline up and down, and we're looking like we're going up 8 or down 8. So our amplitude is 8, so then we get rid of B and we get rid of D. And the next one is what is the frequency. So what we know is V equals lambda F, and we know V is 18, and we need to look at what our wavelength is. All right, and so we need to go from corresponding points on a wave. So if I come for this part of the wave, it's going up, it's coming down, and it's coming up again. There is corresponding points, and that's 6 centimeters. So 6 centimeters, not 6 meters, 6 centimeters divided by 100. Frequency, and that's 0.06. So our frequency then is 18.06. And so when we do that, I reckon we're going to get 300, aren't we? And so C is our answer. All right, question 14. Different regions of the, let me scroll it first. Different regions of the electromagnetic spectrum have distinct applications in society. Which one of the following best associates a particular region with the possible application? All right, so infrared. What's infrared about? Infrared cameras, we hear about that. Infrared is about heat. All right. Visible light. Now, what do we got? Visible light. Visible light, that's about stuff we see. All right. See with our eyes. Ultraviolet. What can we use ultraviolet? Well, we use ultraviolet for sterilising. And X-rays, what do we use X-rays for? Well, they're used for medical stuff, aren't they? So let's have a look. So heat, we're looking here, so we could have that. Thermal imaging, all right. Stuff we see, oh, not water sterilisation, optical microscopes. So there's there, sterilising, water sterilisation. There we go. So now, so far, we've now got down to only one of them with 3 ticks, and then the medical imaging one. So D has 4 ticks. All right, so key thing here is, what is infrared? About to heat. Visible is about stuff we see. Ultraviolet, we use that for sterilising. And X-rays, well, we use that for medical stuff. See if we've got broken bones and the like. All right, so what I would do is, you find on your internet or something, you can find just a small image which you can put on your sheet of notes, which would summarise the electromagnetic spectrum and bits of the electromagnetic spectrum, what's what and what's used for what. There's heaps of stuff on the internet that you can get for that. And I will put that on my sheet of notes. It won't take up much space, but could be quite handy. All right, one more question in this video we will look at, and that's question 15. Okay, so question 15. A physics class is investigating dispersion of white light using a triangular prism. Which one of the following best shows the principle of dispersion? Okay, so for dispersion, that's the splitting up of the light. Now, something that I've used forever is that violet varies violently. All right, so using that mnemonic, VVV, violet varies violently. So if violet varies violently, means that violet bends more than any of the others. So we've got light coming in and we've got light going out, and the one that's bent more here is violet, the one that's bent more here is violet. So we're down to those, and then C and D, it's the red's bending more, but violet varies violently. Now the other thing, we've got to pick out between these two. Now, the bending of the light occurs at both the triangular glass prism, both when the light enters the prism and when it exits the prism. So B says that it doesn't occur, it all just follows the same path as it enters. That's not true. The violet does bend a little bit more. So then B's out, and so now we're left with A as our best alternative. All right, so that's it for that group of questions. Next group of questions, another video. And as always, with all of these are just my way that I've done things. So, you know, you speak to your teacher, so your teacher might have some other ideas or maybe even better ideas. Also, the examiner's reports, making sure you look at them and see what they've got to say about the questions.